Hi. So this demo is brought to you by Gabriel,
And Marcos.
and the project overview we have is that this project covers Python programming using a few Python libraries such as Bottle3, NumPy, CV2 from OpenCV, as well as others, to create a smart Raspberry Pi security camera. Additional software that we used are from Amazon Web Services. To discuss the setup process and how we went about to doing this project, Marcos created two programs, Face Trainer and Face Recognition. With the Face Trainer program, feed files of people that we want the program to recognize. So images into this program. This program, the Face Trainer, then allows the face recognition analysis to be able to recognize and give feedback if it's a stranger or not, according to the accuracy it gets during the analysis. And at the same time of once the analysis is done in this program, it also sends a file to the cloud under AWS. Okay, and to get into the AWS portion, what we had to do in AWS was to create a simple notification system topic. And the way you do that is by configuring the notification to identify in an event, to have the simple storage S3 publish. Okay. Then the next step to do is to update topic policy to allow S3 to publish messages. And at the same time, what we also did was to create a S3 bucket. And then you configure S3 bucket, and by doing that, we create a facial analysis bucket to contain files that the FaceRec program creates in the Raspberry Pi level. Okay. Once we do both of these, we are able to subscribe the S3 bucket to the SNS email notification, and that is the setup process. Marcos will now go into the programs.
Hey, what's going on, everybody? What you're seeing here is the Face Trainer Python script, which is a script that trains all of our saved images in our image set, that which will be later used in our main Python script for live facial recognition. So here at the top, we need to import our Python libraries in order to do our training. So at the top, we have to import CV2, which is the OpenCV library. We need to import NumPy, which is great for working with arrays. We then need to import from pill, or pillow, it's abbreviated, and import our image library. Pillow is really great for opening, manipulating, and saving many different image file formats for it to be Python friendly. And then we need to import pickle, which is basically a process of converting Python objects, in our case, our images, into a byte stream to store it into a file or a database. So as you can see here, we have to call in our base dir variable. This variable basically is wherever this face trainer file is, it can pull from the other subdirectories. So then we call in our image dir variable, which is pulling all of our images that we want to train. So from our data set, these images are, for instance, images of myself, other celebrities, just so the machine has basically a variance of images to train from. So below the image dir variable, we have to call in a face cascade variable where it calls in the CV2 cascade classifier for facial recognition. If you see here, we are calling the hard cascade frontal face XML, which is a face recognition algorithm that is basically capable of capturing faces. However, for our project, we have to do some manipulations for our purposes. So if we go down to our for loop, we are looking for files in our image dir variable where all of our images are. And so if our image ends in PNG or JPEG, Python will take those images and start creating labels, as you can see here. Once labels are developed, we then call in we start utilizing the pillow functions. So we start converting the images to be Python friendly, give it a size, finalize the image, and then we start into a NumPy array. After our images are placed into a NumPy array, as we just said, we then created a new variable, faces, and as you can see here, faces. This faces variable is utilizing the face cascade multiscale. This is basically the area or a barrier of where our future training is going to take place. So as you can see here, we're fetching every image in the image array. We're giving it a scale factor of 1.5, mid neighbors 5. So as I said, it's just like a square box in a sense, like it's a barrier of where our training is going to take place. So after we declared our faces variable, which is, as I said, is finding the barrier or where our training is going to look into, we then call in a for loop, X, Y, W, H in faces. So it's looking into that barrier. And we're going to do our training in our region of interest here. So it's taking the image and outputting many numbers per second. It's really fast paced recognition and storing those data numbers into our X train and Y labels. So we're appending those data. We then develop a pickle file in the form of WB or writing bits as F or as file. And we're going to go ahead and dump our label IDs inside that pickle file. And after all said is done, we train with our training labels in our NumPy array, etc. And what comes out is a trainer YAML file. So after all what I just said, all the recognition process, the barrier, etc., it's going to store all that into a trainer YAML file, which is then utilized in the main Python script for live face recognition. So that takes us into our face rec file. All right, so this is the face rec script, and this is where all the magic happens. So this script is basically a script that will capture live recognition and prediction using the trainer YAML file from the trainer script I was just talking about. So back at the top, we have the same libraries imported except for two. Boto3, which is Boto3 and secrets. So Boto3 is an AWS SDK that gives us the accessibility to send files to AWS, and secrets is actually a directory in our file system which obtains the keys for our S3 bucket. AWS, you need to have special access for the items or such as Raspberry Pi, giving them access to send files into AWS in a sense. So that's what it is. So then we get into our cascades, and instead of just using only the face cascade, we decided to add eye cascade and smile cascade. Adding these cascades not only made our recognition more complex, but the recognition is given sort of a boost in recognizing our faces. So we then call in our recognizer, trainer YAML file. Remember, this has all of the data from our trained images, from our trained file as we were just talking about. So we are importing them here. We then open our pickle file as reading bits instead of writing bits as before. And we're sort of fetching all of the labels. Then comes our while loop. Now, ladies and gentlemen, this is our project. This while loop connects everything all together. So starting off with, so while true, we are going to have the frame open. So that's what ret and frame is. We're setting the variables into the cap read. So capture read. And so according to the documentation of hard cascade algorithms, any face recognition needs to be ran in the color gray. Not exactly sure why that is. You just kind of have to take it as it is. And then we kind of do the same thing as we did in the trainer, right? We declared our faces variable, and we are making the size, we are making the barrier for where our recognition is going to look into live feed. So as we said before in the trainer, we call in our for loop once again, X, Y, W, H. We are looking into that barrier again. And we are doing our recognition, our region of interest of gray. So that's where, as I said, the documentation you need to recognize in gray. But our frame that you will see on the demo on our desktop or PC or Mac, whatever you use, the camera feed would come out in color. So we convert it into color, but behind the scenes, the camera is running in gray for recognition. So that leads us into our variables for recognition prediction. So as you can see here in this if block, if conf is greater than or equal to 45. So when we're looking into the YAML file, and all those numbers are being outputted, as I said, those numbers live feed. If the machine thinks that the face looks like, if my face looks like Marco's, if it's greater than or equal to 45 prediction recognition, it's gonna print the ID, labels ID, so Marcos, in a font of Hershey Simplex. It's a CV2 label font. And then it's gonna give it a color scheme of blue. Stroke 2 is like the size of the box, the width. And then we put the text. So it's gonna put the text of the name and everything, and put all the color scheme, etc. And then we get into our CV2 rectangle, which is the square box that you will see in the live feed. It is the square box that is showing around the face. So you will see that. And then we kind of do the same process with the eyes recognition. We do the rectangle recognition box, smiles. So when it detects a smile, it's gonna put a box around the mouth and it will display as if like the machine is recognizing a smile. Then lastly, we get to our variables of image item. So this is basically when someone takes a picture on their phone, there's like an image. So there's like a title of the image. So in our instance, when the face is recognized, the image is there's gonna be a snapshot in time, and that snapshot would be given a name. So let's say the first face that popped up on camera, the first image will come out in the directory 0.png, string number.png. So it'll be 0.png, the next photo will be 1.png, etc. So once images are being written and put into the directory, we get into our if and elif block, and here the most important section of the blocks are the elif block. So if the num is greater or equal to 150,000 images, we're gonna break it, so it's gonna end. So remember when I said when a face is recognized, there's gonna be a snapshot, the label of the image 0.png, 1.png, as faces are recognized. If the amount exceeds 150,000 in the database, in our snapshots, basically, the code will end. We do this so like if our security camera is running at night, let's say, or during the day, and it's gonna keep rolling and rolling until 150,000 images are taken of a face recognition. So that takes us into Boto3. So here you can see we have our client variable. We're calling in our Boto3 client S3. We imported our access keys, as I said. And so for file in our directory, if the file ends in a .png, we're gonna go ahead and upload to our bucket, so PySecurity. And once all the upload is done, the output on our main script will print done. And at the end of all that, the capture of the live feed of the camera feed will end, and the whole code will end. So I'll pass it back over to Gabriel, and he will finish out the logistics of our project.
Thank you, Marcos, for doing that. OpenCV Raspberry Pi with AWS. Here is a diagram of how the physical here's our logical process of how it will work. Okay, so a person walks in front of a PyCam, and then as that person is doing that, approaching the house or building, the PyCam triggers OpenCV, the program's, it would trigger the facial rec program, and then that is activated here, and then once the file is created in the face rec program, the file system as Raspberry Pi is then sent, the file in the file system of Raspberry Pi is sent over to AWS, right? And into the S3 bucket that we created. And then the SNS topic that we configured is then triggered by the update in the S3 bucket, it sends the email notification over to the house owner, okay, or the building owner, and informs them.